Hi everyone, welcome to part 2 of our paper 2 preparation series. Today we will cover chapter 11 to 22 focusing on essential points to memorize including acid and bases, organic chemistry and many more. I will simplify the concepts and share effective exam strategies to help you succeed. If you haven't seen part 1, be sure to check it out. Grab your notes, subscribe for more, and let's prepare to excel in paper 2. Okay, starting from chapter 11, acid and bases. So, what is the must known material you need to memorize for your exam is these three definitions about acid, base, and alkalis. Acid, the common definition for acid, the student usually thinks that any compound that is actually or any solution that is reacting with a base to neutralize it, it is actually an acid. But that is not the right definition. The right definition is a solution or a compound that will release proton in a solution, or we can say hydrogen ion. Hydrogen ion is also called proton. So releasing the proton ions or hydrogen ions in the solution is actually called an acid. Where is what is a base? A base is a solution, or you can say a base is a compound that will neutralize the acid. Okay. So these base can be either metal oxides or hydroxides. If this base is soluble in water, then we call it alkali. Okay. A soluble base is called an alkali. Don't think that the proton acceptor is an alkali. No, base is a proton acceptor, but alkali is a soluble base. Okay. Any soluble solution that can accept the proton, it is called an alkali. If it is not soluble, then it is not an alkali. Okay. So soluble base is actually an alkali, and a base is actually a substance that will neutralize acid, or you can say that will accept the proton. Okay. So if it is accept the proton, then it is a base. Another definition you have to remember it. What is neutralization reaction? A neutralization reaction is a reaction in which acid and base react to form a salt and water as a product. Okay. Acid base reactions are called neutralization reaction. So what does neutralization means? That the pH will become neutral, that is 7. Okay. Because now we have water and salt. An example of neutralization reaction is HCl, an acid reacting with a base, sodium hydroxide, and at the end, the product will be NaCl, which is a salt, and water. Okay. So now let's see what is the pH scale and how you can measure that which compound is an acid or a base, which solution is acid or a base. Whenever we have an acid, the pH will always be less than 7. Okay. So for all the acid, the pH is always lower, that is lower than 7. 7 is the neutral pH. And if any solution that has a pH more than 7, then it means it's an alkaline solution. Remember that. I think this is a more common concept and everybody knows that what is the pH value for the acid and base. But this is for your memorization. Now let's see some common acids and their salts. So which acids will produce what type of the salts? We can see one by one. Hydrochloric acid usually give chloride salts. For example, we can see over here HCl, it's a hydrochloric acid. So it is giving you a sodium chloride, a chloride salt. Okay. Sulfuric acid will usually give you sulfate salts, and nitric acid will usually give you nitrate salts. So these are some of the acids and their common salts which you can see in the product when there is a neutralization reaction. Now, this is a very important question related to the indicators, and at least one question in your exam will come will appear in your exam related to the color. With the color of different indicators if the solution is an acid or it is a base. So you have to memorize these colors of the indicators. There are different type of indicators. One is a litmus, another one is phenolphthalein, the third one is methyl orange, and the fourth one is universal indicator. The litmus paper always turns red when it is in acid. Okay. So the color of the litmus is always red in acid and it is blue in the alkali. So you have to remember or you have to memorize these colors because at least you will get one question related to the color. Let's see for phenolphthalein. Phenolphthalein color always is colorless in acid. If you add a phenolphthalein in acid, it will change to colorless. Whereas in alkali, the color will always be pink. Okay, so if the color of the phenolphthalein changed to pink, it means the solution is actually an alkaline solution. Another important indicator is methyl orange, and so many questions related to methyl orange already came in the exam from in 2023 and 2024 paper, in which they ask you about the color of methyl orange in acidic solution. Or sometime they will give you the color that, okay, the color of the methyl orange is red. So which solution is this one? So if they give you a red color, then it means it's an acidic solution. And what will be the color of methyl orange in alkaline solution? It will always be yellow. So in alkaline solution, the color of methyl orange and the actual color is actually orange. Okay, so the color will change to red if you add it into acid, and if the solution is an alkaline, the color will change to yellow. Universal indicator. So universal indicators are actually the indicators that just show you the full pH range of the acid or alkaline solution with different colors. So it will not come in your exam. Usually these are the three main indicators that will appear in your exam, and you have to choose the color. So memorize these colors so you can get one free marks, because at least one question will be related to the color. Now let's see chapter 12, preparation of the salts. What are the common questions that will come in your exams, and what is the most common knowledge you must know related to this chapter? Let's see first. In the preparation of the salts, you have to remember the solubility rules. For solubility rules, you have to remember that which type of the salts are soluble and which type of the salts are insoluble in water. So all the nitrates, whenever you get the nitrate salts, they are always soluble in the solution. So the solubility is that they are soluble. If you get sodium, potassium, or ammonium salts, they are also soluble. So these are the things you have to memorize. Okay, these are not the conceptual things, these are the just the memory things that you have to remember, so that you don't get confused in the exam. All the salts of sodium, potassium, and ammonium are soluble. Let's see for the chloride. Most of the chlorides are soluble, except there are two options. One is silver chloride and lead chloride. These are the two chloride that are not soluble in the water. Okay, let's see about sulfates. Sulfates also, most of the sulfates are soluble in the solution, except for the barium sulfate, lead sulfate, and calcium sulfate. These are insoluble salts. Okay, so you have to remember what are the exceptional cases that cannot be soluble in the solution or in the water. Most carbonates. Let's see about the carbonates. Carbonates usually are in the form of precipitate or in the solid form. They will never be soluble in the solution. So most of them are insoluble, except for three cases, that is sodium, potassium, and ammonium, which is already given here. That sodium, potassium, and ammonium salts are always soluble in water. Okay. So what does it mean? If you get sodium sulfate solution, or sodium carbonate, they will be soluble in water. So sodium, potassium, ammonium are the exceptional cases, because these salts are always soluble in the water. Okay, but all other carbonates except these three will be insoluble. Most hydroxides are also insoluble in the solution, except for sodium hydroxide, potassium hydroxide, and ammonium hydroxide. Again, the same, these three: sodium, potassium, and ammonium. These are the exceptional cases. Their salts are always soluble in water. Okay, only the hydroxide and carbonates are insoluble, but the exception is for sodium, potassium, and ammonium. Okay, so they are insoluble except for sodium, potassium, and ammonium. So you have to remember these compounds and their solubility. Let's see the preparation of salts. So when you are preparing the salts, there are two common methods, or you can say three common methods. Actually, three common methods depending upon the solubility of the salts. We already have discussed the solubility of the salts, that which type of the salts are soluble in water. You just have to memorize them. So now when you will know the salt, the type of the salt in your product, then you will also know, it will be easy for you to remember the method, that which method will be useful to prepare such salts. So we have two types of salts, one that are soluble and the other one that are insoluble. So for soluble salts, we have two types of the method that we can use to prepare salts. And for insoluble, we have just one method, okay? So insoluble salts means the product will be insoluble. So which method you are going to use for insoluble salts? That is just a precipitation method, okay? In which you will get the precipitates. And then these precipitate, you can easily filter them out and then you can dry and you can get your product. But if your salts are soluble, then there are two methods. First is the metal oxides or carbonates if you are using them and they are insoluble as a reactant, but their salts are soluble. Okay. When their salts are soluble, then which method you are going to use? And another method is that in which the both the reactants are soluble with each other and you get also a soluble salt. So your reactants are also soluble and your product is also soluble. So what will be the method? We can see now one by one. If one reactant is insoluble, okay, for example, if an acid is reacting with a metal oxide and that metal oxide is not soluble in the acid, so what will be the method you will use? And the product is soluble, okay? So your product is soluble, but actually one of the reactant is insoluble. Then you will use this method, add excess solid method. What does it mean? You will add more amount of that reactant, which is insoluble, okay? And then later you can filter it out and then you can see which method we will do. So I can show you it in more detail. First method, add excess solid method. What you have to do, this is for the soluble salts, right? What does it mean? It means your product will be soluble, but your reactant, one of the reactant is insoluble. So for example, for soluble salts, for copper sulfate, if you are doing this reaction, add excess base or metal carbonates to an acid. So acid is a solution. And then when you will add the copper sulfate, it will not be soluble in the acid. Okay, so you can add more amount of the copper sulfate. So the amount that will react with the acid, you can get your salt, you can get your product that is a salt, but actually it is soluble in the acid. Okay. So what you will do, you will just filter it out so the reactant copper sulfate is removed. So you will filter off the unreacted solid and then now you have your only liquid is remaining, right? In your solution. So the remaining liquid, you can just evaporate the water and remaining will be the salt because your salt was soluble. So you have to use the evaporation method to get your salt as a product. Okay, so this is the method that we usually use for the soluble salts. Another method in which both the acid and both the reactants like an acid and a base both are soluble because we know that alkali is a soluble base. So whenever there is a reaction between an acid and an alkali, you will get a salt. And in this method, because both the reactants are soluble, so what will you get? Your product will also be a soluble. So when both are soluble, the reactants are soluble, and your product is also soluble, then you have to use titration method. So titration is a method in which both the reactants are soluble and also your product is soluble. So what you will do, add an alkali to an acid using a buric. Then you will use an indicator to find the neutral point. When the color of the indicator will change, it means the reaction has been neutralized. So once the color has changed, you will repeat again this experiment without using an indicator. Okay, and the time at the point at which you get this neutralization reaction, at that point you will stop your reaction and then you will again evaporate your solution and you will get the crystallized salts. Okay, so this is the method. These are the two methods that you usually use for the soluble salts. But now if your salt is insoluble, it means your product is insoluble, then that is a simple method, just a precipitation reaction, because whenever the acid or a base will react, you will get the precipitate. And when you get the precipitate, you will know that, okay, your product has been formed. So you get your product easily by filtering it out. So when you mix the two soluble salt solution, the precipitate will form. And then what you can do, you can just filter this out. And the remaining product that is a solid is actually your product, right? You can just let it dry and then you can take that salt that is your product. Okay, so the precipitation method is a method that is used for the insoluble salts. Your product, if it is insoluble, then you have to use the precipitation method. But if your product that is a salt and it is soluble in the solution, that you then you have to use a method that is either titration method or excess solid method. Okay, excess solid method. So these are the three methods when you are preparing the salts. I hope this point is clear to you now. Let's see now chapter 3. The main points you have to remember related to chapter 13. Chapter 13, the periodic table, is a very important chapter. At least 2 to 3 questions usually come in exam related to this chapter. So the main thing you have to remember about chapter 13, the periodic table, is the main components of periodic table. And what are those main components of the periodic table? It's actually the group and the periods. Most of the students usually get confused in the group and period. So group is a vertical column. Most of the students get confused. They think this is a group, but this is not a group. This is actually the period, and this one is a group. Okay, so group is a vertical column and the horizontal rows are actually the period. Group number always decide the oxidation state of an element. Also, it will tells you that what is the number of electrons in the outermost shell. If any element belongs to group 1, it means its outermost shell has only 1 electron. So group number decides or indicate the number of outer shell electrons, whereas the period number will tell you the information related to electron shells, that how many electron shells are present for in a particular element. For example, if any element belongs to period 3, it means it has 3 shells. Okay, and if it belongs to group 1 and third period, then what does it mean? It means it has 3 shells. In the first shell, it has 2 electrons. In the second one, of course, the maximum electron will be 8. And in the third shell, because it belongs to group 1, so the third shell will have only 1 electron. So this is an element that belongs to period 3 and group 1. Okay, so group 1 will tell you the electron number in the last shell, and period will tell you the number of the shells an element have. Okay, in your periodic table, we have 3 different type of the elements. One is a metal, the other one are non-metals, and the third one are metalloids that have both the properties of metals and also non-metals. Okay, so let's see where the metals are present. If this is your periodic table, this is the left side, and the left side, all of the elements are actually metals. Okay, and on the right side you have non-metals. So in between are the transition metals. You can see it in your periodic table already given in the blue color. Okay, and here if you see, there are some metalloids in the group number 4. In group 4 we have some metalloids, for example, that is silicon. These metalloids are actually present at the borderline of the metal and non-metal. Okay, so we have only 4 to 5 metalloids, and silicon is one of the example of those metalloids. But metalloids questions are not very common in exams, so you have to give more focus to metals and non-metals. And in metals and non-metals, not all the elements are important. You have to remember 4 main groups that will usually come in the questions, will usually come in the exam related to these 4 groups. And those groups are the first one, the group 1, alkali metals. And the group 2 is also important. If they ask you, you have to remember that group 1 are always called alkali metals. And group 2 metals are called alkaline earth metals. Please remember this one, that group 2 are called alkaline earth metals. So in exam, they can ask you that which elements are alkaline earth metals. So the metals that belong to group 2, they are alkaline earth metals. And group 1 are just called alkali metals. Second group that you have to remember is group 7, that are halogens. Halogens means that are able to make the salts. Halogens are the elements or the non-metal that can make salt. We call them halogens. So group 7 are the non-metals. You have to remember their properties and trends. Another important group is noble gases, group number 8. Okay, this is also given in your chapter 13, and you have to remember their properties. Last but not the least is the transition metals. They are the central block and they are present in the center of the periodic table. So these are the four main elements, or the you can say the groups that you have to remember their trends and their properties. So now let's see one by one which properties you have to memorize for each of the group. Group 1 has only one electron in their last shell. Just remember that, okay, if they have one electron in their last shell, it means it is very easy for them to lose electron, right? So if it is very easy for them to lose electrons, it means their chemical properties are dependent on electron loss or gain. So it means they are the most reactive metals. So the most reactive metals are group 1 metals because they have only one electron in the last shell. So compared to all other metals, these alkali metals are the most reactive. And if you go down in the group, if you see the trend within the group from top to the bottom, the reactivity will increase. Why reactivity will increase? Because if you go down at the bottom, the number of the electron shells will increase. So what does it mean? When the shells are far from the nucleus, it is more easy for the electrons to be loosened. Okay, so they will lose the electrons more easily. That means they are more reactive. So that's why reactivity increased down the group in alkali metals, but it is opposite in halogens. Reactivity decreased down the group in non-metals because the properties of the non-metal is to gain the electrons. Okay, so it is very difficult for the halogens to gain electrons if they are far from the nucleus, because nucleus is positive. It cannot attract the negative electrons because it is so far from the last shell, right? So attracting the electrons will get more difficult for these halogens. But here the thing is that they have to lose electron. They don't have to attract electrons. So if the distance is getting higher, it means it will be more easier for the metal to lose electrons. Okay, so that's why the reactivity increased down the group for group 1 metals, but for group 7 known metals, the reactivity will decrease down the group. Please remember this concept. It is very important and it will be helpful for you in your exam. And other important property of the alkali metals are they are very soft and they are very reactive. So usually we store them in the oil, because if you don't store them in the oil, they will just react with oxygen. So that's why they are usually stored under the oil to prevent the reaction with air or the water, because they are very reactive, right? So, and what is another property? They are soft, they have a low melting points, and they react with the water to form alkaline solutions and hydrogen. So, for example, when sodium will react with the water, it will give you sodium hydroxide. That is an alkaline solution. Okay, they have a low melting point. You remember that the metallic bonds are very strong. They have a very high melting and boiling point. Why they are using the word low melting point? It is compared to other metals. It is not compared with the non-metals. Okay, compared to other metals, group 2, group 3, and transition metals, the melting and boiling point of alkali metals is lower. Okay, it is not compared to the non-metals. Of course, compared to non-metals, their melting points are always higher. But when you compare all the metals, the group 1 metals have the lower melting points. Let's see for halogens. How halogens always have the reactivity decreasing down the group. I already have explained why, the reason. And then the second important thing, that halogens are always present in a diatomic molecule form. Okay, they are never present as monoatomic in nature. They will always be present as a diatomic molecule. And those diatomic molecules are always colorful. All the halogens make the colorful molecules. For example, the color of the fluorine is yellow. For chlorine, it is green. For iodine, the color is gray. Okay. For bromine, the color is brown. So you can see all of them have different colors. So it usually make the colorful diatomic molecule. And other important information is about the halogens is that in the displacement reaction, the most reactive element always replace the less reactive element. What does it mean? Because the reactivity is decreasing down the group. So on the top, we have fluorine in group 7. And after fluorine, we have chlorine. So what does it mean? It means fluorine can displace chlorine in any of its salt. If you have sodium chloride, and you react it with fluorine, the fluorine can replace the chlorine and you will get sodium fluoride, okay? Because fluorine is more reactive. But chlorine cannot displace fluorine because chlorine is less reactive than the fluorine. So in displacement reaction, only the most reactive halogen will displace the less reactive halogen. Now let's see the properties of noble gases. Noble gases belong to group 8, so it means they have 8 electrons in their large shell. So this means these elements, they don't have to react with any other element to make a compound. Because why elements usually react? Because they need to make their large shell electron number 8. If they can't make it, then they are not stable. So usually the metals or non-metals react to stabilize themselves. They want to stable their large shell electronic configuration. So in noble gases, if the electronic configuration is already stable, so it means they will not react. So they are the most unreactive gases. And in nature, they are usually present as monoatomic atoms. Okay, so they are the monoatomic elements that are present in nature, unreactive, inert due to full outer shell electrons. And they are monoatomic gases. Usually, their function is maybe they can be used in lights. For example, the neon is used in red lights, or for welding sheets in balloons. We can use them in balloons. A helium gas is used. So you can remember that helium is used in making balloons, in filling the balloons, and in making the neon lights. We use usually the red light for neon. Okay, so these are some of the uses of noble gases. Now let's come toward transition metals. So transition metals, if you compare them with the group 1 metals, they have more density. They have more density as compared to the group 1 metals. They are more dense. They have high melting point compared to group 1. Okay, group 1 has the lowest melting point compared to all other metals. So this is another, they have higher melting points than group 1 metals, but they are less reactive. Why they are less reactive? Because their oxidation state is not 1, just like group 1. Okay, so transition metals, they are less compared as compared to the group 1 metals, okay, but they have high melting points. Another important factor or another important property of the transition metal is that is different from all other metal is that they have variable oxidation state. What does it mean? That's the name in the transition. Transition means they can change anytime. What can change anytime? The oxidation state. They have different oxidation state because most of the time their two shells are actually incomplete. It's not only the last shell, but sometimes their second last shell is also incomplete. That's why they have different oxidation states. Sometimes they will lose 2 electrons from their last shell, or sometimes they will try to lose 3 electrons so they can have the both the shells stable. Okay, so that's why you just have to remember the more detailed concept you will learn in your A levels. So here you just have to remember that their outer electron shell, the second last and the last one, are actually incomplete. So that's why they have different oxidation state. And this is the only property of transition metals. All other metals and non-metals have fixed oxidation state except for the transition metals. Okay, because of this different oxidation state, they are used as catalysts. All the catalysts that are used in different chemical reaction, they are actually transition metals. Okay, the other metals cannot be used as a catalyst. For example, in the Haber process, the catalyst we use is iron. In the contact process, vanadium oxide, vanadium is actually a transition metal. So most of the catalysts that are used in different chemical reactions are actually transition metals or their oxides. I hope these points are clear to you. Now let's come toward chapter 14, the most important topic and the most important concept you have to remember from chapter 14. Let's see what you have to remember. First of all, you have to remember the properties of metals. We already discussed some properties of the metals in chapter 13. Now let's see what else you have to remember. Metals are the good conductor of electricity, right? They are good conductor of the heat. You must have to remember this property. This property is for all the metals, okay? There is no metal that cannot conduct electricity. All the metals are good conductor of electricity, and the reason behind is because they have metallic bond. And in metallic bond, they have free electrons to move. So free electrons or delocalized electrons are responsible for electrical conductivity in the metals. Another property of the metals is malleable and ductile. What does malleable means? Malleable means they can easily change their shape. Okay, you can change their shape. They will not break, but they will change their shape. And ductile means that you can change their shape into a wire. So metals are malleable and ductile. What is the reason behind it? If you remember the bonding in the in the metals, it is actually a metallic bond, right? So in metallic bonds we have positive ions layer and delocalized electrons. The positive ions layer actually can slide over each other when you apply the force. So when you apply the force, the layers will slide over each other and the metal will easily lose its shape. It can change its shape and it can also be changed into a wire. That's why metals are malleable and ductile. So what is the reason behind it? Because the metal ions, actually the positive ions, not the electrons, the metal ion layers can slide over each other when you apply the force. So that's why they are ductile and malleable. Now let's see, another property of the metal is that they have high melting and boiling points. I already have informed you that group 1 also have high melting and boiling point, but compared to other metals, they have low. So metals have high melting and boiling point. What is the reason behind it? The reason behind any high melting or boiling point is actually the bonding. So the bonding which is present here is a metallic bond. And what is a metallic bond? It is actually the lattice of positive metal ions in a sea of delocalized electrons. So these electrons and metal ions, they both are oppositely charged, so they attract each other, and this force of attraction is very strong. So that's why these metals have high melting and boiling point. Another important property of metals is that they are shiny compared to the non-metals that have dull colors. But in the the metals, they have shiny appearance and lustrous, and usually they are have very high density. Okay, and the most dense are transition metals. Among all the metals, the most dense are the transition metals. So metals have high density also, and they have a shiny appearance. Let's come towards the properties of the metals. Chemical properties. We have discussed already the physical properties: good conductor of electricity, malleable, ductile, high melting and boiling points. Now let's come toward their chemical properties. First chemical properties is that they are able to make the positive ions. Metal always make positive ions. They will never make the negative ions. It's not possible for metals to gain electrons. Usually they will lose electrons, so they always make positive ions by losing electrons. This is the first chemical property. Second is they react with oxygen to form basic oxide. So most of the metals, whenever they will react with oxygen, they will make a basic oxide. And we have only three exceptional cases, that is aluminium. Aluminium oxide is not basic, but it is also not acidic. Okay, it is amphoteric. You have to remember that. And what is amphoteric oxides? Those oxides that can behave both as a metal oxide, sorry, basic oxide or acidic oxide, depending on the situation. So if aluminium oxide reacts with a acid, then it will act as a basic oxide. But if aluminium oxide react with the base, it will act as a acidic oxide. Okay. So if the other reactant is a base, then aluminium oxide will act as an acid. But if another reactant is an acid, aluminium oxide will react as a base. So this is the property of the aluminium. There is another metal that can also act as a amphoteric oxide, that is zinc. You have to remember these. These are the two common examples. Usually they appear in exam and it is asked that, okay, zinc oxide is a basic oxide, it is an acidic oxide or amphoteric oxide. So you have to choose the option amphoteric oxide. Another example of the amphoteric oxide is the oxide of the lead. This will also make the amphoteric oxide. Another example is beryllium. Okay, this is the fourth element of the periodic table. So lead, beryllium, zinc, and aluminium, they always make amphoteric oxide. There are some more examples, but you guys have to just remember these four examples. They can appear in the exam. So you can choose amphoteric oxide for this one. But all other metals will usually make the basic oxide. Now let's see about the reactivity. We already have discussed that the group 1 metals are the most reactive one. and the reactivity of the group 1 increases down the group. So it means that lithium is less reactive than sodium, and sodium is less reactive than potassium. Okay. So this is how the reactivity increases from top to the bottom. So the bottom metal in group 1 will be the most reactive one. Let's see another property of the metals. Now, this properties of is the property of transition metals. This is a chemical property. Let's see what is the chemical properties of transition metals. The one chemical property of transition metal is already given here in the chapter 13, that they have different oxidation state, right? Another property, a chemical property of transition metal, is that they are less reactive, but they form colorful compounds. All the compounds of transition metals are usually colorful. But if you compare with group 1 metals, they are usually colorless or maybe white in color. For example, sodium chloride. Okay, the compound of the group 1, sodium belongs to group 1. Sodium chloride is usually white color, okay? Or you can say the colorless. So usually the compound of group 1 metals are colorless, but the compound made by transition metals are usually colorful. Transition metals themselves are not colorful except for copper, okay, or zinc, but their compounds are always colorful. Now let's see what are alloys. Alloys are actually the mixture of two or more metals. Why? What is the reason behind making alloys? Because we already have discussed that metals are more malleable and ductile. It means they are soft, right? To make them a little bit hard, we usually, according to the use, if we want to make some useful products and we don't want it to be malleable or ductile, then we usually use the alloys. And how there are some common alloys of that are of the metals that are already given in your book. You have to remember those alloys. One example is a brass, another example is steel, and the third one is stainless steel. These are the three common examples of the alloys. How these alloys are made? Brass is always made with copper and zinc. The mixture of copper and zinc will give you brass, whereas for steel, it is made up of iron and carbon. And stainless steel, it is made up of iron, chromium, and nickel. You have to memorize these elements, that which elements make which alloy. So brass is made up of copper and zinc, steel is made up of iron and carbon, and stainless steel is made up of iron, chromium, and nickel. So let's see now what are alloys. The alloys are stronger and harder than pure metals, and it is a mixture of a metal with other metals or non-metals. So sometimes it can also be a non-metal. So why they become more hard or malleable? The reason is because now they have different size of the atoms. They are together in a layer. So it is very difficult for a layer to slide over each other due to the different size of the atoms present in a same layer. Okay, so when they cannot slide over each other, so the malleability will decrease. That's why it makes them harder to slide, and alloys are less malleable compared to their pure metals. Okay, for example, copper is more malleable compared to the brass. Iron is more malleable compared to steel. Okay, so that's why we use different type of alloys according to our need. So because if, for example, the steel, we want to use the steel to make the vehicle's body, so we cannot use iron. It's better to use steel. We can use the steel. Okay, it will be more helpful and it will be less malleable. So that's why we use steel. Okay, these are some of the examples of the alloys. Now let's see for the chapter 15, reactivity of the metals. This chapter is also related to metals, but only related to the chemical properties. So reactivity series, this one question will come must in your exam related to the reactivity of the metals. And to remember the reactivity series of the metals, that which metal is the most reactive one, you have to remember this mnemonic. I have written a mnemonic for you, that please stop calling me a careless zebra. Instead, try learning how copper save gold. If you remember this line, it will be easy for you to memorize that which metal will come first, and the first metal will be the most reactive one. P for please and P for potassium. So potassium is the most reactive metal. S for stop, S for sodium, C for calling, C for calcium. So this is how you can match your mnemonic with the actual reactive elements. Okay, so potassium is the most reactive, then sodium. After sodium, we have calcium, magnesium, aluminium, carbon. Okay, now we have carbon also here. Why we had carbon added in the metallic series? I will give you the explanation later when we will see how metals are extracted. Okay, so the reaction, that's why we have added carbon and hydrogen in this reactivity series. They both are non-metals, but we want to compare their reactivity compared to carbon and also hydrogen. So all these metals are more reactive than carbon. And let's see, zinc, iron, tin, and lead. They are less reactive than carbon, but they are more reactive than hydrogen. And let's see what is the least reactive one. That is these metals, copper, silver, and gold. These are the least reactive one. They are even less reactive than the hydrogen. So now let's see reaction compared to their reactivity. So if the metals are more reactive, it means they can easily react with any substance, right? So if you see potassium, sodium, calcium, they can easily react with water. Water means the cold water, simple room temperature water, they can easily react with it. And then they will produce hydroxide, an alkaline solution, and also hydrogen gas. But after calcium, magnesium, and aluminium, they cannot react with the cold water. They can only react when the water is hot. You can say the word steam, okay? When it is steam, it can react, and then the product will not be the same. It will not produce a hydroxide. It will just produce oxide. For example, when magnesium will react with steam, it will produce magnesium oxide, not magnesium hydroxide. Okay, so you will get magnesium oxide and hydrogen. So when metals react with the water, we get metal hydroxide. But when metals react with steam in the form of gas, then the product will not be a hydroxide, it will always be an oxide. Okay, so this is the reactivity of the metals with the water. Now let's see the reactivity with the acid. All the metals that are above hydrogen can react with the acid. So if you see potassium, sodium, calcium up till lead, they all can react with an acid. Okay, so that's why this is how you have to remember the reactivity series. If you remember the reactivity series, you will easily know that which metals can react with acid. Let's see about displacement reactions. In displacement reaction, it is similar to like halogen reaction, in which a less reactive metal is displaced by a most reactive one. What does it mean? If you have a potassium salt, for example, you have potassium chloride, so and you add sodium in it, sodium will never displace potassium. Okay, so you will still get potassium chloride and sodium, there will be no reaction. But if you have a sodium chloride and you add potassium in it, then you will get the product as potassium chloride, and sodium will be reduced. Okay, because the potassium will displace the sodium. Potassium is more reactive, so it can displace the less reactive one. So this is how the reactivity series works. So if you remember this position from potassium to gold, how the reactivity is going down, then you can easily predict the reactions. Okay, which reaction can take place in the presence of which metal. Okay, let's see now thermal decomposition of metal compounds. Okay, most of the metal compounds cannot be thermally decomposed. They need a very high temperature to be decomposed. So that's why more reactive metals have a staple compound. But the less reactive metals, for example, copper or silver, that are below the hydrogen, they have very low melting. Their compounds have a very low melting point, or you can say boiling point, so you can easily decompose them. Okay, the decomposition of these copper, for example, if you are using a copper sulfate, the decomposition will be easy, or copper chloride, the decomposition will be easy. Also for silver chloride, it can easily be decomposed. Okay, so there the compounds of the less reactive metals are easily decomposed compared to the more reactive metals. So for example, copper carbonate can easily be decomposed by giving a small amount of the heat. Okay, so what you will get just copper oxide and carbon dioxide. Can be easily decomposed. Why? Because copper is the least reactive among other metals. Except for silver and gold, it is the most reactive. Okay, so now the reactivity also, I told you that why we have placed carbon and hydrogen in the reactivity series. Now this is the reason, extraction of metals. Because in the nature, we don't have metals in their pure form. They are usually in the form of their ores. What is the ore? Ore is actually a mineral in which we can find a metal in its compound form. It can be oxide or it can maybe in other form of compound, okay? But it is not present in its element form. So how we can extract a pure metal, it depends upon its reactivity series. So all those metals whose reactivity is less than the carbon, you can easily extract them by reacting with carbon or carbon monoxide. Okay. So what will happen when reacting with carbon monoxide? These metals will get reduced and you can easily get the metals. So all those metals that are below the carbon, they can be easily extracted by reduction with the carbon. Okay. For example, you can get a pure iron from its ore. How you can get a pure iron from its ore? Just by reacting the carbon with the iron in a blast furnace. Okay. Because iron, if you see over here, iron is less reactive than the carbon. Okay. But all those metals that are above carbon in the reactivity series, you cannot extract them with the help of carbon. Okay. So what we have to do, you have to do an electrolysis method. Electrolysis is the only method that can give you pure metals if their reactivity is greater compared to carbon. Okay. So if reactivity is greater than carbon, potassium, sodium, calcium, magnesium, aluminium, you can get only through electrolysis. One of the example is already given for aluminium in your book. If the reactivity is less than carbon and more than hydrogen, then you can get it through the process of reacting them with the carbon in blast furnace, right? Okay, so what about those metals that are less reactive than hydrogen? In nature, actually, they are present in a form of pure metals, copper, silver, and gold, because they are less reactive. So also you can get them in their free form or in their metallic form. Okay, so that's why they are usually present in nature in a form of pure metals, copper, silver, and gold. Except these three metals, all other metals in nature are present in a compound form, but not in their pure form. This is all related to chapter 15. Now let's come toward chapter 16, in which there were two methods given for the extraction of the metals. First method was the use of blast furnace, and the example given was of iron, because iron is less reactive than carbon, so you can easily extract it by using carbon in a blast furnace. Okay, so method of the reactivity was how first you have to add the carbon above in the so because the carbon is above in the reactivity series compared to iron, so you can use this method to extract iron. And the other method is electrolysis, which is given in your chapter 16. And this method is only used for the elements that are more reactive compared to carbon. So the example given was for aluminium from its ore, that was bauxite. Okay. So first of all, blast furnace, the iron extraction method. The raw materials that were used for the iron extraction method, and you have to remember in the exam, is coke. Okay, coke, the carbon that will be helpful for the reduction of the iron. And hematite is actually the ore of the iron that is naturally present in the nature. And why we will use limestone? Limestone will be used to remove the impurities in the blast furnace. Okay. So this was the method that was used for the iron extraction. Okay. And for aluminium, it was a simple method, that is electrolysis. And we already know what is how the electrolysis process takes place. Okay. So now let's see about the corrosion of the metals. Most of the metals, they can easily corrode because they are reactive, right? So they can easily react. And one of the most common example of the corrosion of metals is iron. Iron can easily corrode, or we can say it can easily rust when there is oxygen and water present. In the presence of water and oxygen, if both are present, iron, oxygen, and water, if anyone is missing, then the iron will not rust. But for rusting of iron, both oxygen and water must be present in the environment, and then the iron will be rusted, and you cannot get back your pure iron. So, how we can avoid such methods? Because it is the loss. You can lose a lot of metal in this case. So, how you can avoid this? There are different methods to avoid the corrosion, and these methods are given here. Okay, prevention method for rusting is one. You can use a barrier method. A barrier method means you can do a coating of anything on the top of your iron or the metal that can easily corrode. For example, you can do painting, oiling, or coating with the plastic, so it can protect the iron. But the disadvantage of this method is that if there is a small scratch on the plastic or on the painting, so the area that will be exposed will get easily rusted. Okay, the paint or the oil can only protect if it is on the surface of the iron. But if there is a little scratch, you can see the rusting of the iron. So this method is not very useful method. Let's see another method, galvanizing. For galvanizing, it is also a coating method, or you can say it's like a painting method. But instead of using a paint, you use an other metal, or you can electroplate it. Actually, electroplating method you coat iron with the zinc. For example, zinc is actually more reactive than iron. So when you place the zinc, you do the coating of the zinc on the iron. What will happen? The zinc will act as a sacrificial protection or a sacrificial metal. It will What will happen? It will itself oxidize first, so it will protect the iron. Okay, so itself it will rust, but it will protect the iron. That is called galvanizing method. Another method similar to galvanizing is sacrificial protection. Okay, in sacrificial protection, we attach more reactive metal compared to the zinc. You can see the more reactive metal can be magnesium blocks, and usually it is used on the ships because most of the time ships are made up of iron or steel, and they are present all the time in the water, and these ships can have easily corrosion. So how we can avoid the corrosion of these ships that are made up of steel or iron? We cannot do the coating of the zinc on all over the ships, so it's better to use some more reactive metals. We can use their blocks, or we can attach these small patches of the metals on the ship. So what will happen? Actually, these reactive metals will oxidize first. They will act as anode whenever the oxygen will attack. Okay, so they will oxidize first, and they will give, because oxygen actually need the electrons from the metal. So whichever metal will provide the electron, oxygen will be happy. So who will sacrifice first? The most reactive metal. So most reactive metal, for example, if you attach the magnesium blocks on the ship, the magnesium will lose its electrons first, and oxygen will grab those electrons. So now oxygen is happy and magnesium has sacrificed. And what about the iron? Iron is still the same. Okay, so this is how sacrificial protection works. So you can prevent the rusting. The best methods are actually galvanizing or sacrificial protection. So these are all the main topics that are related to the metal chapter, chapter 14 to chapter 16. Now let's come towards the most important points you have to remember related to chapter 17, that is chemistry of our environment. First of all, you have to remember the air composition. Sometime in exam, they can ask you which gas makes up 78% of the air. Okay, so you have to remember the percentage weightage of all these gases. Nitrogen makes up 78% of the clean, dry air. Okay, oxygen 21%, argon is 0.9%, and carbon dioxide is almost 0.04%. So the remaining one are the trace gases. You can see the noble gases, they are the remaining gases or the remaining percentage of the water. Oh, sorry, percentage of the air, and we also have water vapors in the air. Okay, so this is the main composition you have to remember. But most of the time, you have to remember these four compositions so you don't get missed, you don't get confused in the exam. Okay, so nitrogen makes almost 78% of the air. Now, when you already have memorized the air composition, you have to remember now what are the pollutants that are polluting the air. The top composition is about the clean, dry air, right? So now let's see which pollutants are now present in the air and from where they are arising, from where they come. So let's see now, first of all, the main reason for polluting the air is combustion. Whenever we burn the fuels, we get carbon dioxide or carbon monoxide. There are two types of combustion, complete and incomplete. Complete combustion means when there is plentiful oxygen, when there is an excess supply of oxygen, and you get carbon dioxide as a product. So, this carbon dioxide, if you see the concentration is very low, it's just 0.04. But now, because of combustion of the fuels, this composition has been increased a lot. So that's why carbon dioxide is also a pollutant because its percentage has increased from 0.04%. So this is one of the pollutant that is the result of complete combustion. And sometime if there is incomplete combustion, which means then when you have limited supply of oxygen, then instead of getting carbon dioxide, you will get carbon monoxide. And it is also a pollutant gas and also very carcinogenic gas because it is toxic for the human life. Okay, so if you inhale it, it will reduce the oxygen transport in your blood, and at the end, a person will die. So, carbon monoxide is the most carcinogenic or toxic gas. Now, let's see the main air pollutants one by one. First, we already have discussed the carbon monoxide. Okay, the carbon monoxide and carbon dioxide both are the pollutants. Okay, carbon monoxide, it is the what is the source? It's the incomplete combustion and toxic. What is the effect? It is the toxic for the human health. Let's see another important pollutant is sulfur dioxide. What is the main source of sulfur dioxide? It's also burning the fuels. Those fuels that have sulfur in them, if you burn them, you will get sulfur dioxide. They will react with oxygen and give you the sulfur dioxide. And what is the main effect of the sulfur dioxide? It is the main component of acid rain. So acid rain, the main reason behind the acid rain, there are two gases. One is sulfur dioxide and the other one is nitrogen oxide. So what is the source of nitrogen oxide? It is the car engines. In cars, usually from the cars, whenever the fuel is burned, you get nitrogen oxides. Okay. So nitrogen oxide and sulfur dioxides are the main components of the acid rain. There are two main environmental problems we are facing. One is acid rain and the second one is global warming. Okay. So for global warming, the gases that are responsible are carbon dioxide and methane, CH4. For acid rain, the two main gases you have to remember is nitrogen oxide and sulfur dioxide. Okay. Sulfur dioxide and nitrogen oxides are not responsible for global warming. They are just responsible for acid rain. So you have to remember which gases are responsible for acid rain and which gases are responsible for global warming. And then you also have to memorize their source. Sulfur dioxide source is the combustion of the fossil fuels that contain sulfur. The source of nitrogen oxides is actually the cars or the vehicles, okay? So the car engines. For carbon dioxide, it is usually the combustion of the fossil fuels, complete combustion of the fossil fuels. And for methane, it is usually from the waste of the animals. The waste of the animals usually produce methane gas, okay? So now what is acid rain? Acid rain is a rain because mostly the rain is water, right? So its pH should be neutral, that is 7. So if the pH of the rain is lower than 7, it means that is an acidic rain because the two main gases that are responsible for the acid rain are SO2 and nitrogen oxide. Whenever they mix with the water, they will make an acid. Sulfur dioxide will make sulfuric acid, whereas nitrogen dioxide will form nitric acid. And these both are the acids. And sulfuric acid is a very strong acid, right? So now the rain will become acidic. Okay. So what are the effect of acid rain? It can damage the building, it can damage the aquatic life, and it can also kill the plants. It can affect the forest. So these are the main damages that are caused by acid rain. Okay. So how we can reduce acid rain? How we can reduce? We have to first reduce the cause root. And the cause root is sulfur dioxide and nitrogen oxide. Sulfur dioxide, what is the source? It's the use of fossil fuels that have sulfur in them. So what we should do, we should try to avoid the use of the fuels that contain sulfur in them. Okay. Now let's see for car engines. Nitrogen oxide is produced in car engines. So what we can do, we can try to avoid using okay, how we can try to use catalytic converters. What are catalytic converters? Actually, in catalytic converter, we have transition metals. It's the same from the word catalytic. Okay. So what will happen actually in the car engines? Most of the time we get nitrogen oxide and carbon monoxide as a product of the combustion. But if you add them in a catalytic converter, they will react with each other and you will get nitrogen and carbon dioxide. So these two are less harmful as compared to carbon monoxide and nitrogen dioxide, right? So you can use catalytic converter in your car engine, so there will be no production of nitrogen dioxide. But you can see that still there is a production of carbon dioxide. So this carbon dioxide is actually responsible for the global warming from the combustion, and also from the cars you are getting the carbon dioxide, and this is responsible for global warming. So now let's see how we can control the global warming and what are the gases that are responsible. We already have discussed that the gases that are responsible for global warming, they are called greenhouse gases, and these are two: carbon dioxide and methane. Okay. So what is the main function of these gases? What they will do, they will trap the heat. Okay. Whenever the sun rays enters into our earth, the earth will absorb those rays, and the quantity which earth needs, it will just absorb that much amount, and the remaining one it will reflect back. Okay. So when the earth reflect it back, in our environment we have carbon dioxide and methane in a large quantity. What they will do, they will trap that heat, that they will trap those rays, and then they will not send it back to the sun. Okay, what they will do, they will not send it back to the atmosphere. They will just trap them. They will just send half of them back, but the half of them again back to our earth. So what will happen? The temperature of the earth will increase. Okay, this is how they are increasing the temperature, or they are a reason for the global warming. Okay, so for example, this is your sun and this is your earth. So when the rays enter this earth, earth will absorb some of these rays and it will reflect some of the rays back. If, for example, it just need one ray, and it will reflect back the two rays again because it don't need. So here we have a lot of carbon dioxide and methane present in our atmosphere. What they will do, they will try to absorb these rays. Okay, so what will happen? After absorbing, they will reflect back one of the ray, but will send back again the other ray to the earth. So this ray is actually now increasing the temperature of the earth. Okay, so I hope this point is clear to you now, that how the global warming, how these gases are responsible for global warming. So they are actually absorbing these rays or absorbing this heat and then reflecting it back to the earth. Now let's come toward a very important topic that is related to organic chemistry, chapter 18. Okay, so what is organic chemistry and what are the main points you have to remember related to this chapter? First of all, you must know what are organic compounds. All those compounds that have carbon in them, they are, most of the time we call them organic compounds. But for, of course, carbon dioxide is not an organic compound. So most of the organic compounds should have carbon and hydrogen in them. Okay, carbon, hydrogen, or any other compound, if it is present, then we call them organic compounds. Okay, so they have different functional groups, and according to the different functional groups, they have different homologous series. Homologous series is actually the group. These groups are called homologous series depending on the functional group. So, and for example, if we have alkane, it has a different functional group. Alkenes have different functional groups. So all alkanes belong to one homologous series. Alkenes belong to another homologous series. Okay. So in organic compounds, we have now two types of compounds most of the time. That is only hydrocarbons or organic compounds. What are hydrocarbons? Hydrocarbons are also organic compounds, but in hydrocarbons, we have only hydrogen and carbon is present. No other element present in these compounds. For example, it is simple from the name. Hydro means hydrogen and carbon means carbon. So for example, methane, this is a hydrocarbon. okay, because it has only hydrogen and carbon, no other element present. So there are two types, or there are two homologous series that are of hydrocarbons. One homologous series is called alkane and the other one is alkene. These are the only two homologous series that are actually hydrocarbons. We don't have any other types. So two types, alkanes and alkenes. So what is the functional group in alkanes? Alkanes don't have any functional group, okay? They are just made up of carbon and hydrogen. And the general formula for alkanes is CnH2n plus 2. You have to remember the general formula, so it will be easy for you to understand that which compound is this one. If you can see the general formula, it will be easy for you. For example, if you see this is CH4, so C is 1, then H2n plus 1 plus 2 should be 2 into 1 plus 2. So it means it is alkane actually because it is following this formula. So methane is the alkane. Okay, and another important thing you have to remember in your organic chemistry is the number of the carbons will actually decide the name of the organic compounds. How you can decide the name? For that, you have to remember the first six elements. Okay, first six carbons. If there is only one carbon present in any organic compound, then the name will start with MET. If there are two carbon present, then the name will start with ETH. If there are three carbons, then the name will start with PROP. Okay. Four carbons is BUT and five carbon is PENT. Six carbon is HEX. Okay. So these are the names you have to memorize so you don't get you don't do any mistakes in your exam, because sometimes they will not tell you the formula. They will just tell you that propane is this. So how you will know what is propane? Propane means it has three carbons and it belongs to alkane group. Okay, alkane group has A and E at the end. So if it is methane, it means this compound has only one carbon and it belongs to alkane group. If it is methane, okay, methane is not present in alkene group, so we can just ignore. If it is ethene, for example, then what does it mean? It means that this compound has two carbons and it belongs to alkene group. Okay, so this is how you have to remember. So what about alkenes now? Alkenes are unsaturated hydrocarbons. Okay, they are also carbons, but they are unsaturated. So what is the difference between saturated and unsaturated? It's simple. Saturated means that there is no chance for another element to enter in this compound. Okay, no other element can enter into this one because all the bonds are complete, because all of them are single, so you cannot break them, right? But for alkenes, why we call them unsaturated? Because at least they have one carbon carbon double bond. So if any compound has at least one carbon carbon double bond, it is called as unsaturated. Okay, so alkenes, this is the functional group of alkenes. They have a double bond in them. So what is the general formula for alkenes? It is CnH2, and you have to memorize this one. Alkenes and alkanes both are colorless compounds. So how you will differentiate between them? There is one test that is called bromination or addition reaction. What does it mean? If you add bromine in a reaction of alkenes or alkanes, what will happen? Alkanes, there will be no change in the color because they are already saturated. Bromine cannot replace and it cannot be added. Okay, there will be no addition because no bond is free. But in the alkenes, this double bond will break and the bromine will be added to these carbon. So what will happen? The color of the bromine will change to the colorless. Okay, so if the color of the bromine was brown, it will change to colorless. So it means a reaction has taken place. So that's why this is how you can differentiate between alkanes and alkenes. Alkenes, when bromine is added, the color will change from brown to colorless. But if the bromine is added to alkane, the color of the bromine remain the brown and alkane will be still colorless. So you will see two colors, two layers. It means that there is no reaction taking place. Now let's see for the homologous series. I already have told you homologous series actually depends on the functional group. So every compound which have the same functional group, they belong to one homologous series. So a family of the compound with the same functional group, of course, when the functional group same, then the general formula will also be same. And if the general formula and the functional group is same, functional group is actually deciding the chemical properties in an organic compounds. Okay, so they will have similar chemical properties. In homologous series, all the compounds that belong to one homologous series, they will have similar chemical properties, but will have different physical properties. And the physical properties, why they will be different, it will depend on the number of the carbon atoms present. If the carbon number is less, then the melting and boiling point will be also less because the number of bonds will be less. If the carbon number increase, then the boiling point will also increase. So this is how you have to remember some of the properties of homologous series. All the compounds in a same homologous series have a same functional group, same general formula, and similar chemical properties. Why similar chemical properties? Because of the same functional group. And what is the difference? It's the difference is only in the physical properties. Why in the physical properties? Because in one homologous series, we can have different number of carbons, okay? The general formula will be same, but the carbon numbers can differ. So increase in the carbon number will increase the melting and the boiling point of those compounds. Now, what are the some of the functional groups that are very common and already given in chapter 18? First is alcohol. First is alkanes, and we already have discussed the alkanes. They belong to hydrocarbon group, and then the second group is alkenes, right? Okay, the third one is actually alcohol. And what is the functional group? Is OH. The functional group in alcohol is OH. In alkenes, we have a double bond. It is a functional group. In alkane, we don't have any functional group, okay, because all the carbon bonds are single. So in alcohol, we have a functional group that is OH. All those compounds that have OH in them, they belongs to alcohol group. For example, this is an example of the alcohol group. Now, another homologous series or the functional group you can see is COOH, that is carboxylic acid group. So if they have a carboxylic group, it means these compounds are called carboxylic acid. And if you have two carbon, one of the example, because ETH means it has two carbons, so it is ethanoic acid. We will call it ethanoic acid. Why? Because it belongs to carboxylic acid. Alkenes have double bond in them as a functional group. So if it is has two carbons, you can see over here. So ETH is because of two carbon, and because the functional group is alkene, so the last name will come here. So ethene. The name will be ethene. Okay. For ethanol, ETH, it has two carbons, and the name will be anol. Why anol? Because alcohol's names end with anol. So this is how you have to remember that the functional group actually and the number of the carbon will decide the name of an organic compound. The number of carbon and the functional group name, they both decide the name of an organic compound. Another main concept which is given in chapter 18 is isomerism. In isomerism, it means that those compounds which have same molecular formula but their display or structure formula is different. Okay, for example, in alkenes you have butene. So butene has two isomer. I can show you the structured formula of butene. We have butene means it has four carbon, right? And it has at least one double bond. Why double bond? Because it is E and E. So it means it is four. It has four carbons and it has at least one double bond. So we can make a double bond over here. Now we have to see the general formula of the alkenes. The alkene general formula is CnH2n. So it means if you have four carbons, then how many hydrogens should be present? It should be eight. So now let's see where we can adjust these eight hydrogens. Three will come here because you see carbon can make four bonds. So one, two, three, four. Here we will have only two hydrogen because carbon can make four bonds. Now here we have already one, two, three, right? So we already have three bonds. So only one hydrogen will be placed here. So now the electronic configuration of this carbon is complete. One, two, three, four. Please be very careful when you are drawing the structure. You cannot randomly place hydrogen anywhere. You have to complete the four electron shells electron number of the carbon, okay, and 1 for hydrogen. So now let's see, this carbon needs how many more hydrogen? Only 2, because 2, we already have the bonding here. So the remaining one is 2. So now carbon also have now 4 bonds, 1, 2, 3, 4. So if you count these number of hydrogen, it will be 8. Can you count them? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is one of the formula of the butene. So this butene is called but-1-ene. Why 1-ene? Because the double bond is present on the first carbon. Now I will make another structure formula that is maybe on the carbon 2. So if I make a double bond on carbon 2, carbon like this, so it means now this is another structure of the butene, and we will call it but-2ene. Okay. It will have same number of hydrogen, same number of carbon, but structural display is different. Because if you see here, you have 3 hydrogen here, right? 1 hydrogen here, 1 hydrogen here, and then you have 3 hydrogens here. So the number of hydrogens are 8, right? The number of carbons are also same. But if you see here, this carbon has only 1 hydrogen, but here, the second carbon, if you see over here, it has 1 hydrogen, right? But the third one has 2 hydrogen, but here we also have 1 hydrogen in the third carbon. It means the structure is not the same. So this is what we call structure isomers. Those compounds that have same molecular formula but different structure formula. So these are called structure isomers. In most of the time in alkenes, we have structure isomers. Okay. So the compounds that have more than the 3 or the 4 carbon or more than 4, they usually make the structure isomers. Now let's see the combustion of hydrocarbons. So whenever we know that organic compounds, whenever they burn in a supply of oxygen, we will always get carbon dioxide, hydrogen, water, and a lot of heat. Okay. So whenever hydrocarbons burns in the presence of oxygen, these hydrocarbons can be alkenes, they can be alkanes, and other organic compounds, even alcohols, carboxylic acids, they will always produce carbon dioxide and water. These are the only 2 products you will get whenever organic compounds react with oxygen. So organic compounds and oxygen, you will always get carbon dioxide and water. Okay. But in incomplete combustion, of course, you will not get carbon dioxide, you will get carbon monoxide. Now let's come towards chapter 19, some of the reactions that are related to organic compounds. Okay, so first of all, the reactions that are given step by step are related to the homologous series. So the first homologous series we have in the organic compounds is alkanes, and they are also called hydrocarbons because they have only carbon and hydrogen present in this compound. Okay, these are the only 2 metals. So alkanes, what are the reaction? The common reaction the alkanes can do, they are only few. First, they can do combustion reactions. And in combustion reaction, the product will always be carbon dioxide and water. This product will always be same for all the reaction of the organic compounds with oxygen. It doesn't matter, it is alkane, it is alkene, it is alcohol. Whenever they will react with oxygen, your product will always be carbon dioxide and water. You can see one by one. Another reaction the alkanes can do, because they cannot do addition reaction, so they can do substitution reaction. What does substitution reaction means? That one hydrogen, because for example, if we have methane over here and it reacts with the chlorine, so this chlorine can replace any of the hydrogen. So because hydrogen is less reactive than the chlorine, so chlorine can replace this hydrogen and you can get CH3Cl, and the other product will be HCl. Okay, so this is called substitution reaction, in which one element is replacing another element. So substitution reaction usually takes place with halogens, group 7 elements, and then hydrogen will be replaced by that halogen. And usually substitution reactions do not take place at room temperature. You need a UV light or sunlight for these reactions to take place, because the alkanes are mostly unreactive. They are the most unreactive compounds compared to all other organic compounds. Okay, combustion, I already have told you that we will get carbon dioxide and water. But in complete combustion, of course, you will always get carbon monoxide. That's obvious. Now let's see the reaction of alkenes. First reaction of alkenes, I already have told you whenever they will react with the oxygen, you are going to get carbon dioxide and water. This is same like alkenes. Now let's see some new reactions. Alkenes can also do addition reaction. That is not the property of alkanes, right? Addition reaction is only the property of alkenes because they have a carbon-carbon double bond. So what will happen? This double bond, one of the double bond will break, and that element whichever they are reacting with, either it is bromine or it is chlorine, it will be added over here. So you will get a new product, and that new product name will be alkane. Now it will be alkane, okay, not alkene, because double bond has already broken. So whenever they react with the halogen, the product will be dihalogenoalkane. What does it mean? Di means because two bromines are added if it is reacting, so it will be two. Okay, so we can say di halogen bromine. Bromine is a halogen, so we can say dibromoalkane. Okay, and alkane can, it depends. If the bromine is reacting with methane, so you can say dibromomethane. Okay, or ethene. If it is reacting, of course, it cannot react with methane because we don't have methane in the alkenes group, so it can be ethene. So we can just say dibromoethane. Okay, so this is how the reaction of addition reaction takes place. Whenever in addition reaction alkenes react with the halogens, you will get dihalogenoalkanes. Okay. Another reaction of the alkenes is addition reaction. Addition we already have discussed. So in addition reaction, we have two types. We have discussed the reaction with halogen, and the other reaction can be with hydrogen. So let's see one example. For example, we have ethene. So ETH means it has two carbon, right? And E means it has a double bond. It belongs to alkene group. So you have to remember the general formula for alkene. So general formula for alkene is CnH2n. So if your carbon number is 2, then hydrogen will be 4 according to this formula. Okay. So let me make the structure formula for C2. So C, we have double bond. Of course, it should have a double bond, and the remaining H should be attached here. So you can easily see that carbon is making 4 bonds. So it is the last shell has been complete. For this carbon is also making 4 bonds. Okay. So this is the formula of ethene. Now when the hydrogen will react, H2 will react here. So this double bond will break and H will attach here and here. So now there is no double bond. So what does it mean? Now this one is, before it was ethene, now it becomes ethane because now it belongs to group 1. That is the alkane group. There is no double bond, and the formula of the general formula of alkane is CnH2n plus 2. And that's right, right? We have 2 carbons, and now we have how many hydrogen? 6 hydrogen according to the formula. So now this is ethane. This is also a addition reaction in which we will only get one product. 2 reactants are reactant, and we are getting one product. And the other one was halogen. I already give you the example. So if we are reacting it with the bromine, so here we will get bromine here, and also here the bromine. So now what will be the name? The name will be same. This is what? Now we have double bond, right? No double bond. So the name will be same. We have 2 carbon. So the name will be again ethane. But we have to adjust these names. Now, how we can adjust the names? We can see how many bromines we have. We have bromine here. So we can write bromoethane, right? Now we have to see the number. If the number of bromine is 1, then it is bromoethane, but the number of bromines are 2. So for 2, we will use the word di. So this is dibromoethane. Now you have to look also for the location of the bromine. So the bromine, the first bromine is present on the carbon 1. The second is present on carbon 2. So you can just write 1,2-dibromoethane. So this is how you name the organic compounds, okay? So the name of this compound will be 1,2-dibromoethane. So these are the addition reactions for the alkane group. Now let's see the reactions of alcohol. Alcohol has a functional group OH, right? And whenever I already have informed you, whenever there is a combustion reaction for organic compounds, you will always get carbon dioxide and water, right? The homologous series does not matter. All organic compounds will give you carbon dioxide and water whenever they will react with oxygen. This is the combustion reaction in which they react with the oxygen molecule. There is another reaction that takes place when alcohols react with monoatomic oxygen. It's not a molecule, it is just a monoatomic oxygen, and it will usually come from a oxidizing agent that is called potassium dichromate or potassium magnate. Okay, so it can be acidified potassium dichromate or potassium magnate. So what will be your product now? The alcohol will change into another homologous series, that is carboxylic acid. You can see over here C2H5OH has converted into CH3COOH. One O has been added. So from where this O has came? This O has came from potassium dichromate. Okay, only one O. This is an oxidation reaction. This is not combustion. Why we cannot call it combustion? Because here the oxygen is not present in the form of a molecule. We are just using a monoatomic oxygen ion. Okay, so you will get carboxylic acid. Don't get confused with the combustion of alcohol and the oxidation of alcohol. Oxidation of alcohol will always produce carboxylic acid, and the combustion of alcohol will always give you carbon dioxide and water. Now let's see the another homologous series, that is carboxylic acid, and their functional group is COOH, right? So COOH, the carboxylic acids, are actually the weak acids, and whenever they will react with the metals, they will produce salts. Okay, so acids whenever react with the salt with the metals, they will produce salt and hydrogen gas. Whenever they react with carbonates, again they will produce salt but carbon dioxide and water. Okay, and whenever they react with the base, it's simple. We already know whenever acid react with the base, we get salt and water. So in all these reactions, we will get salt for must. If it react with metal, it react with carbonates, or even if it react with the base. But the second product will be different. If it react with the metal, one will be the salt, the other one will be hydrogen gas. But if it react with the carbonates, one will be the salt, the other two will be carbon dioxide and water. If it react with the alkali, then the salt and the water will be the product. Another important reaction which carboxylic acid do is the formation of the esters. Where how esters are formed, it is another homologous series, and these esters, what is the functional group in the ester? It is actually C double bond O. We call it as an ester bond. Okay, so C double bond O, how you will get whenever alcohol react with carboxylic acids. So the homologous series, that is the third one, alcohol group, and the fourth one, carboxylic acid group. Whenever they react, they will give you a new homologous series, a new functional group, that is the ester. Okay, so ester is the fifth homologous series that is not given in your book as a separate, but we already, you can see in chapter 18 and 19, it is written that the formation of the esters, and the formation of esters actually belong to a new homologous series. Okay, for example, if ethanoic acid is reacting with ethanol, it's alcohol. So what will be the product? It will be ethyl ethanoate and water. How you name the esters? Okay, to name the esters, it's just a simple trick. You have to name the alcohol first. You can see anol, it means it is alcohol. So alcohol name will come first. So ethanol name will change to ethyl. Okay. And then ethanoic acid, simply OIC will change to ATE. So the carboxylic acid name will come after the first one, that is alcohol. So the name will be ethyl ethanoate. If it is propanoic acid, then you can say ethyl propanoate. Okay, this is how you name the esters. Okay, and the second product you will get is the water. So how we make the esters? It is actually a condensation reaction, because there is a small product, that is water. Water is produced. So what does condensation reaction means? In which when two compounds are reacting and a small molecule like water is produced, we call such reaction a condensation reaction. Okay, so this is a condensation reaction which is between alcohol and carboxylic acid, and the products are esters and water. Okay, for such reactions, for the formation of the esters, a catalyst is always required, and this catalyst is actually acid catalyst, that is H2SO4. Why we need this catalyst? Because this reaction is usually reversible. But if you add an acid, then this reaction will not be reversible. Okay, it will be only one-sided reaction. So why we need the catalyst? Not only to speed up the reaction, but also we don't want the reaction to be reversed. So what are the properties of the esters? Usually the fruits, when you smell the fruits, you eat the fruits, the taste of the fruits is actually because of the esters. They have different types of the esters in these fruits. That's why we have different tastes of the fruits. Also, the flower smell. Why the different flowers have different smells is because of the ester. They have different ester compounds. Okay, so the esters are actually, they have a very pleasant smell and they have a very uh, nice flavor. Okay, so that's why esters have a sweet smell and a fruity smell. That's why most of these esters are used in perfumes also, and also flavoring the different dishes. We can use them in the flavors in the bakery industry and also in the perfume industry. Esters are very commonly used. Okay, these are some of the reactions that are related to chapter 19, and you have to memorize them. Now let's see chapter 20 of the organic chemistry, that is petrochemicals and polymers. Okay, so some of the fuels are given in chapter 20 and you have to remember them. These fuels are coal, natural gas, and petroleum, right? So petroleum is actually a mixture of a lot of hydrocarbons. So how you can get the smaller hydrocarbons or the smaller organic compounds for petroleum? For this purpose, you have to do the process of fractional distillation. Okay, so what is crude oil? We also call it petroleum. Okay, so petroleum is actually a mixture of hydrocarbons, and how you can separate them? By different boiling points, because most of these mixtures or these hydrocarbons that are present in petroleum, they have a very small difference in their boiling point. So that's why we cannot just use the simple method of distillation. We have to use a method of fractional distillation. Okay, so fractional distillation is a method in which you can separate the mixture by using their different boiling points that are very close to each other. So through the fractional distillation, you have to remember what are the 8 fractions you are going to get when you do the fractional distillation of petroleum. So these are some of the fractions you are going to get: refinery gas, petrol, kerosene, diesel, fuel oil, and bitumen. So the lowest boiling point is for refinery gas because they are the smallest hydrocarbons you are going to get. The smaller hydrocarbon means they have less number of carbon. So the carbon number, if it is less, then they have of course, the lowest boiling point. But if the carbon number will increase, the boiling point will be the highest one. So that's why bitumen has the highest melting or the boiling point. And bitumen is, that's why we use in road surfacing. It's mostly liquid, a very high viscosity liquid. Fuel oil we use in ship and industrial fuel. So you have to remember their uses. Refinery gas is used as LPG. Petrol, we already know it is used as a car fuel. Kerosene is used in jet. Diesel is used also as a vehicle fuel, and fuel oil, I already have told you that it is used in the ships and as an industrial fuel. Okay, so the melting point will increase if you go down through the fractional distillation. So from the top fraction you will be the refinery gas, and at the bottom you will just get bitumen. So trend down the column in a fraction. So if you see the trend down, the boiling point is increasing. Okay, so this bitumen has the highest boiling point. The viscosity is also very high. It's a gas. It's a liquid, right? Slowly they are changing into liquid, and this liquid is more viscous. It is more thick compared to these liquids. Okay. Similarly, viscosity I already have discussed. It will also increase, and smokiness will also increase. When you burn them, the color of the smoke will also be more darker. What about the flammability? The flammability will decrease. Whenever they will react with the oxygen, the flammability will decrease. The combustion, they will produce less heat. Okay, so the refinery gas will produce the highest heat compared to the bitumen. Okay, so that's why flammability decrease, but boiling point, viscosity, and smokiness will increase down the column. Now, this is the first step, fractional distillation. So from petroleum, you get a lot of small hydrocarbons or alkanes. Okay, so alkanes are the only product you are going to get from fractional distillation. So from where we will get the alkenes? So what is the source of alkenes? So alkenes you can get from these alkanes, which you already have get from the petroleum, right? So what will be the process to get alkenes now? The process is called catalytic cracking. Cracking means you break the alkanes into smaller alkane and alkenes. So your product will be shorter alkanes and alkenes. So the long chain alkanes, for example, bitumen or fuel oil, can be converted into shorter alkanes and alkenes, okay? Because the shorter alkanes and alkenes are more in demand compared to the long chain alkanes, okay? They are not very useful. So smaller chains are more useful because they are gases, or they are can be used as the fuel gas or the fuel oils. So they are more in demand. So how we can make the alkenes and smaller alkanes? Through the process of catalytic cracking. So it requires the heat and catalyst. That's why we call it catalytic cracking. Cracking means to break them down. And to break anything, we have to supply heat, right? And catalytic means it needs a catalyst. So catalytic cracking will always require heat and a catalyst. So it will provide the alkenes for making the polymers. Now for these alkenes, we can also make polymers. So what are polymers actually? Polymers are actually the long chain monomers when they are attached together and they make a large compound with millions of monomers. We call it a polymer. Poly means multiple. Okay, so made up of multiple monomers. So there are two types of the polymers. First, polymers that are made by addition reactions, and we also call them what is the name for these polymers? They are the simple polymers, or we cannot simple polymers, but we can call them like these polymers actually are homologous polymers. What are homologous means? The monomer is same in them. Okay, they are made up of same monomer that is repeated again and again. So such polymers are called homopolymers. So these are homopolymers, okay? And what are homopolymers? That are made by addition reaction. So addition reaction will always produce homopolymers. And you remember the addition reaction is the property of alkenes. So every time if you get a homopolymer, the result will be because of addition. Okay, what is addition reaction? In which only one product is formed, okay, not the two products. So made by addition polymerization of alkenes, you will get one type of polymer that, for example, if ethene, so many ethene, for example, this is ethene, right? We have two carbon and four hydrogen. So how we can get a polymer from ethene? When short, these ethene are repeated again and again and they combine with each other. So this ethene will break its double bond and it will try to attach another ethene here. Okay, so now this is your polymer. If it continues, then it is actually your polymer, right? So this reaction will be, this monomer will be repeated again and again, and you will get a long chain that is called a polymer. So this is the ethene polymer, so we can call it polyethene. Okay, you don't have to change the name to ethane because there is no double bond. No, for polymers, the name will remain the same. You just have to use the word poly. So for ethene, when it makes a polymer, it will become polyethene. Okay, so the monomer is alkene and the polymer is a long chain. So what are the uses of addition, the polymers that are made from the addition polymerization? They can use in plastic and they are non-bio, but these plastics, we already know that they are non-biodegradable. So they are the actual cause of pollution. But we can recycle them again to reduce the waste and conserve the resources. So what is the use of these polymers? We can use them in the plastics, right? But the plastics are non-biodegradable, so they can cause pollution. Now, another type of polymerization is condensation polymerization. I already have told you what is condensation. When two compounds react and a small compound is also produced as a product. Two products are made, but one of them is a very small molecule, for example, water. So the reaction where monomers with two functional groups will join, and then with the elimination of a small molecules, usually water or HCl. Okay. So this is called condensation polymerization. For example, so if alcohol means it has only one functional group OH, but the definition is here, it should have two functional group. It means if we have a diol that has two functional group OH and OH, and in between we have any compound in between. For example, we have CH3OH and OH also here. So you can write CH2OH, and here also we have OH, right? So it is a diol. Whenever a diol will react with dicarboxylic acid, it means you have two COOH on the both side of the chain. Okay, you have two functional group. Carboxylic acid means you have one functional group, that is COH. Dicarboxylic acid means you have two functional group of COOH on both sides of the chain. So only those monomers that have two functional group on both the sides of the on their chain, on both sides, then they can only do the condensation polymerization. Okay, so when they will react, they will eliminate water molecule. So once the water molecule is removed, and the other product that is formed, that is called a polymer, and we will have also a water molecule. So there are two different types of the condensation polymerization. In condensation polymerization in chapter 20, you are already given two types of the polymers: amide polymers, okay, and the other ones are the ester polymers. What does it mean? Those polymers that have amide bond in them, they are called amide polymers, and the ester polymers, or you can say polyesters, they are actually the one that have ester bond in them. Okay, so how you will get an ester bond? It is similar. When alcohol react with the carboxylic acid, we get esters, right? So for ester bond, how we can get? When diol, which means dialcohol, will react with dicarboxylic acid. Okay, so what you are going to get, you will going to get ester. So now let's see how we can get an ester. Okay, how we can get it, let's see one by one. So monomers must have two reactive functional groups. Example is dicarboxylic acid and diol. So what we are going to get? Polyester. Let's see one by one. So in between, you don't have to memorize anything for condensation polymerization. You can just remember there is any carbon and hydrogen is present. Okay, but this side we have a functional group that is COOH, dicarboxylic acid. Now let's see for alcohol. For alcohol, we have diol. Okay, it should be dialcohol because it should have two reactive functional group on both of the side. So if you have this one, now when diol and alcohol will react. Why two functional group is very important? Because if it is only one functional group, then the reaction will stop and you will not get a polymer. For polymer, the next polymer can only join if you have a functional group on both the side, right? If these two sides have been used up and there is no functional group, it means a new monomer cannot attach. Okay, to attach a new monomer, you must have a functional group on both the sides. So now when they both react, remember that carboxylic acid will always lose hydroxide ions. So hydroxide ion will be removed from the carboxylic acid, and only hydrogen will be removed from the alcohol group. So what you are going to get? OH and AH will give you H2O, right? So now what is left over here? So it's simple. R, okay, we can change this one. So we have COOH here, right? And then what we have here now, only C double bond O. Can you see here? OH has already been removed. Now this OAO will make a bond with here, right? Again, so this is your actually ester bond. And now we have what here? This box, and again OH. But this H will be removed because it is alcohol. And here the OH will be removed. So you can just say C double bond O and like this line here. So it means it's a continuous one. Okay. So this is actually your ester. So ester bond is, what is the ester bond? That is C double bond OO, right? Now let's see another one. The other example is of diamide bond. Okay. Oh, sorry, amide bond. How the amide bond will be formed? Again, you have to use dicarboxylic acid, right? But not alcohol. Instead, we have to use amide, amine group. Okay, so diamine group. Let's see. We have a diamine. What does it mean? We have NH2 on both the sides. NH2 and NH2, right? And the other one is, of course, dicarboxylic acid. I can make it like this. So COH and COOH both sides. I already have told you that carboxylic acid will always lose its OH. Okay, so when it's lose OH, who will lose hydrogen? Only the amide will lose one of its hydrogen. So what is now left here? If you see how we can make the formula or the polymer, N has lose its hydrogen here. So now the bond will be NH, right? N and H. And this one will remain the same because N will make another bond with another monomer. Sorry. Okay, this will be just a bond here, which will show that, okay, now NH and other monomer can attach here. What is left here now from here? Again, we are just left with N and H. The H has been removed to give a water molecule, right? So now what will come here? C double bond O, right? Because OH has been removed. So the next one is its box. And again, what will come here? C double bond O and then again. So this is actually your amide link. Amide link is made between dicarboxylic acid and diamine. And what is the formula? NHC double bond O. So this is an amide bond, and then this is C double bond O is an ester bond. So in your book, the example given for ester bond is polyesters, or we can say tyrylene. Most of the time in exam, you will see the word tyrylene, not polyester. Okay, so tyrylene is an example of the polyester in which we have carbon, the C double bond O, that is the ester group. But for amide bond, we have two examples given in your book. One is nylon and the other one is protein. Okay. Nylon and protein both have the same amide bond, but there is only a small difference when we will be covering the common mistakes related to chapter 20. Then I will tell you how you can differentiate between nylon and protein. The nylon and protein will always have a same functional group, that is NHC double bond O. Okay. So amide, in amide bond, we have two examples given in our book, that is nylon and protein. They have a amide link. Okay. And protein monomers are called amino acids. They are just made up of amino acid. Whereas nylon monomers are called as dicarboxylic acid, and the other one is diamine. Okay. So diamine and dicarboxylic acid, these are the two monomers from which nylon is made up of. But protein is just made up of amino acid, only one monomer. And we have different types of amino acids. The functional group will remain the same, but inside material, the carbon and hydrogens can be different, right? So we have 20 amino acids in nature. And out of those 20 amino acids, all the proteins are made up of. In different combination, these amino acids join to make protein, okay? And for polyester, only one example. For ester bond, only one example is given, that is polyester, or we can call it tyrylene. Clear? Now, another example is starch and cellulose. This was the example given in the exams before 2022 papers, but I think this will not be now. You will not see this question in your exam, but you can just remember that starch and cellulose, they are made up of glucose monomers. Okay. When glucose monomers joined, they give you starch. And when amino acid monomers join together, they give you a protein. Now, the main difference between condensation and addition polymerization you have to remember is that there are different monomers used. In addition, the monomers are always alkenes, okay? They are made up of alkenes, only one type. But in condensation polymerization, two different types are used. For example, in ester, we use dicarboxylic acid and alcohol, right? And in amide, we use amine, diamine, and dicarboxylic acid. So there are two different monomers that are used to make a condensation polymer. Okay. But for addition polymers, only one type of a monomer is used, that is alkene. Again, a small molecule formation. In addition, polymerization, no small molecule is formed, only one product is formed, that is your polymer. But in condensation, polymerization, you get two products. One product is your polymer, and the other one is a water molecule. Whenever one monomer attach, you get one water molecule. So if millions of monomers attach in condensation polymerization, you will get millions of water molecule. Okay, each bond, each one linkage will give you one water molecule. Now let's see the monomer type. Okay, in condensation polymerization, the monomers must have a bifunction or difunction. You can say difunctional group. It should have two functional group on both of its side each. Okay, each functional group should be on either side of its chain. So if a chain should have two functional group, one on the right side and one on the left side, then only these monomers can do the condensation polymerization. If it don't have two functional groups, one monomer, that they cannot do condensation polymerization. But what about the monomer type? For addition polymerization, you just need a carbon-carbon double bond. Any monomer that has a carbon-carbon double bond or it belongs to alkene group, then it can do the addition polymerization. Let's see now the product. Some of the example of condensation polymerization is polyester, nylon, and proteins, whereas the product in the addition polymerization are polyethylene, polypropylene, polybutene. Okay, it depends. So these are some of the differences you have to remember, or you can just understand them. So it will be easy for you to attempt some question in the exam paper, because at least 5 question in your exam will be related to organic chemistry, at least 5. So if you memorize these concepts from chapter 19, 18, 19, and 20, the 5 marks you can easily get. Okay, this was all related to organic chemistry. Now let's see chapter 21. So this chapter 21 and 22 actually were an important part of the paper 6. But of course, in your exam, you will get at least 2 questions from chapter 21 and chapter 22. So what are the main topics you have to memorize related to chapter 21? First of all, you have to remember the experiment in the experiment, because we are using different apparatus. So you have to memorize the apparatus name, because in exam they can ask any apparatus name. Okay, which apparatus is this? Okay, that is the first thing. Now the another important thing, they can ask you a question related to variables. So there are 3 different types of the variables. You have to remember that what are those variables: independent variable, dependent, and control variables. Independent variables are the variables that usually we change. Okay, and dependent means that what we are measuring, those variables which we will measure in our experiment, are called dependent variables. And control variables are the variables that are controlled all the time, which means they remain same all the time. We have to keep them same. So such variables are called control variables. Okay, so what is fair test? Okay, in a fair test, only you change one variable. This is just, you have to read it, but I think it will not be very important and it will not be in the part of your exam. The most important thing that will be a part of your exam is these purification and separation techniques, because in exam they can give you any example and they can ask you that which technique will be used to separate this salt or whatever the thing. So remember, the first technique is filtration. When you use the filtration method, if there is any insoluble solid present, because in filtration you will easily separate the solid and the liquid. So only you can use this method if you have one liquid and one precipitate, maybe, or one solid. Okay, when in one solution you have a liquid and solid, then you can use the filtration method. It's simple. Okay, and what will be the apparatus you are going to use? Most important is actually the filter paper you are going to use to separate the liquid from a solid. So that is the technique you have to remember. Now another technique is crystallization. So the crystallization method you can only use if your salt or solid is soluble in a solution, if it is already dissolved in a solution or in a liquid, then you cannot use the filtration method because now it is all liquid, right? So which technique you can use to separate that soluble solid from the liquid? You can just use the evaporation method, or you can say the crystallization method. So what you will do in that process, you will heat it so that your solvent evaporates and you are just left with the solid solute. Okay, so this is the another method you have to remember, that crystallization method is used for the soluble solute that is dissolved in a solid. Simple distillation method. Simple distillation method is separating a liquid from a liquid. Okay, a liquid from a solution. And according to how you can use the distillation method, if both the liquids have different boiling points, okay, if the boiling points are different, then you can use the distillation method. Now, what is fractional distillation? Fractional distillation is a method in which you can separate multiple liquids at a time. Okay, so the mixture of the liquids, if we have different liquids and we want to separate all those liquids, then you have to use the method of fractional distillation, same like we use in petroleum. But if you just have to separate one liquid, then you have to use simple distillation method. Okay, remember that. And another difference between simple distillation and fractional distillation is that in simple distillation, the boiling point difference is more, but in fractional distillation, most of the liquids have very close boiling points. Okay, the difference is very low. Now, another technique which we use is chromatography. So, in chromatography, this is also a technique, a separation technique in which soluble substances, for example, inks, we can separate them, these mixtures, and what, depending on their solubility. Okay, so if they have the same boiling points, okay, and they are all mixed together. So how we can separate them now? We cannot use the crystallization method. We cannot use distillation method. So which method we can use to separate them? Usually we use the method of chromatography. And in chromatography, what will be the method? That is the separation by solubility. Okay. Now another method is the descenting heavy solids from liquids. So how you can separate the heavy solids from liquid? It's simple. Just pour off the top layer. For example, if you have sand that is dissolved in the water, how you can just pour off the water from the top layer and the sand will be at the bottom. So this is also one of the technique that is used to separate solid and liquid if your solid is heavier than the liquid. Okay, now let's see what is chromatography. Chromatography is a technique that is used to separate and identify the components in a mixture. For example, if you want to separate some food dyes or inks, you can easily use the method of chromatography. Okay, so chromatography is a technique which is used to separate the or identify the components in a mixture. So how you can calculate the RF value? Usually in the exam, one question will be related to the RF value of the that solute or that substance that is separated from the mixture. Okay, so this is how you calculate that a distance traveled by a substance and the distance traveled by a solvent, and how you have to measure that distance. If you see, if you will look at the question paper in exam, there will be two lines you will see. One is called the front, right? This will be the base front and this will be the baseline, right? This will be the solvent front. Okay. So sometime they will give you the measurements from here to here, but you don't have to look for those measurements. Every measurement should be from solvent front to the baseline. So whenever you are doing the calculations, you have to do the calculation about the measurements that is between these two lines. Okay, so you have to measure the distance traveled by a substance from here to here. Okay, for example, if your mixture is, this substance is here, so you have to measure the distance from here to here. For example, it is 5, right? So you have to write 5. If they give you a distance from here to here is 6, you cannot calculate this one. Okay, you have to just measure from here to here. Now, what is the distance traveled by the solvent? Again, you have to measure the distance from here to the solvent front. This all distance, for example, if it is 10, you have to measure it 10. You don't have to calculate this distance and this distance. Be very careful. Otherwise, you will get a wrong answer. Okay. Then you can calculate easily your RF value. Okay. So RF value, you can easily calculate. You just have to remember the trick that you have to measure from baseline towards the solvent front, not up, not below that. Okay. All the measurements will be from baseline to the solvent front. Okay. Now let's see chapter 22, chemical analysis. This chapter is mostly related to the test of the gases or the ions. Okay. And what things you have to remember, at least one question will come in the exam related to this chapter. So for first thing you have to remember in exam, if they ask you about the purity, how we can check the purity of any substance, you have to choose the answer according to the boiling points or melting points. Okay, these are the only specific options that can measure the purity of any substance. Okay. So because pure substance have a sharp melting and boiling point, so if you see the option of melting or boiling point in the option, you just have to close your eyes and choose that option, because purity can only be measured through melting and boiling point. No other option can be right. Impure substances have various range of temperatures for their boiling or melting point. If, for example, water melting point, a boiling point, everybody knows it's 100. So if it's changed, it boils at 101, 102, it means it has a impurity in it. This is how we can check the purity of any substance. Okay. So usually we check the purity of the substance through the melting or the boiling point. This point you have to remember. Okay, test for the gases. Usually in the exam, they can give you different options. They can ask you which gas is this, and they can give you some observation. So for that one, you have to remember in your chapter, in your paper 6, this information was already given at the end of the paper, right? But in paper 2, you will not get this information. So you have to memorize this information, that what are the different tests that we can use for the gases. For example, for hydrogen gas, the test can be lighted splint. So you will just see a squeaky pop voice. You can hear that sound, and that means the hydrogen has been produced. For oxygen, there will be a glowing splint, and you will see the red lightning. So this is for oxygen. How you can test the presence of oxygen? Through the glowing splint. What about carbon dioxide? This is the easiest one. You can easily see the bubbles if you use the lime water. So lime water is the best method to check the carbon dioxide production. There will be bubbles in it. Okay. And what will happen to the solution? The bubbles will be formed and the solution will turn milky. Okay. Or the cloudy. For chlorine, it's the simple. You have to use the litmus paper. If you use the damn litmus paper, because chlorine has the bleaching properties, so it will change the color of the litmus paper to white. Okay, it will change it to white color. The color will disappear of the litmus paper. So it means it's a chlorine gas. For ammonia, if you use the red litmus paper, the color will change it to blue, because ammonia is not acidic. Okay, so ammonia will change the color of the litmus paper to blue. So these are some of the tests you can do for these different type of the gases. These are the common gases that you have to remember, okay, and their observation. Now let's see for the flame test for the metal ions. So these metal ions, you have to remember their colors. The most common usually that appears in the exam is related to sodium, okay, or potassium. Sodium is always yellow color. Most of the time it's yellow color. The option will be given in the exam. And for potassium, it is like purplish pink. And usually we use the word for that lilac, okay? So for potassium, the flame is always lilac. These are the two common examples that usually appears in the exam. Last time I also see the lithium option that was red color. So these are the three common ones. But you have to remember for calcium and copper also. Calcium flame is blue-green, calcium flame is brick red, whereas copper is blue-green, okay? So in exam, you have to remember the flame colors also. These are the 5 flame colors you must have to memorize so that you don't lose your marks. Let's see for the test of the cations. You have to remember how you can check for the test that which cations are present. Cations means the metal ions, okay? So if you add sodium hydroxide in a solution, you will see the color. If you see the precipitates, what type of the color of the precipitates are formed, you can easily predict that which cations are present. Copper usually give you a blue color precipitate, right? For example, copper hydroxide or copper sulfate, usually they are blue color, okay? So copper ions, if are present in a solution, you will get blue precipitates. If iron 2 plus, okay, iron with the oxidation 2 is present, then the green precipitates will appear in the solution and brown precipitate will appear if the iron oxidation state is 3 plus. So be very careful with, because iron is a transition metal. So it has two different oxidation state and both the oxidation states have different color. So if the oxidation state is 2, you will get the green precipitate. If the oxidation state is 3, then you will get the brown precipitate. Let's see for ammonium ions. And if you add the sodium hydroxide, you are not going to get any precipitate, only you will get an ammonia gas and it will be released in the form of the bubbles. Okay, so you will see the bubbles of the ammonia gas usually, and if you heat it, okay, if you heat the solution, if you don't heat, you will even not see the bubbles of the ammonia gas. Now let's see what are the tests for anions, means non-metal ions, okay? The negative ions. So the most common negative ions are the halogen ions, that is chloride ion, bromide, iodide. For all of them, there is a same test for halogen ions, okay? That is to use nitric acid and silver nitrate. If you add the nitric acid and silver nitrate, the colors will differentiate between these halogens. The test will remain the same. You just add nitric acid and silver nitrate into a solution, okay, into a halogen solution, and you can easily predict which halogen is present. If the chlorine is present, then you will get white precipitate. If bromine is present, you are going to get cream color precipitate, okay, a little bit milky color. And if iodine ions are present, you are going to get yellow precipitate in your solution. What you have to do in your solution, you just have to add nitric acid and silver nitrate. Please memorize this test so it will be easy for you to choose the right option. Now we are left with two ions, that are carbonate ions, very common ions, and sulfate ions, okay? So if in a solution you have carbonate ions, just add the acid and you will see the carbon dioxide bubbles. If you can see the carbon dioxide bubbles, it means that this solution has carbonate ions, okay? And how you will know that, okay, this is only the carbon dioxide gas? Because the solution will also turn milky. You will see the bubbles and also the solution will turn lime. The lime water will be milky, okay? That solution becomes milky. So that's why you can see that, okay, the carbonate ions are present. But if you see no change, then you can try this one. You can add HCl, hydrochloric acid, and barium chloride, okay? Once you add HCl and barium chloride, and you see the white precipitates form, okay, only the white precipitate, then it means sulfate ions are present. So how you can predict the presence of different ions? Through these tests, and the result will tell you. If the results are not the same, there is nothing changed, it means this ion is not present. Maybe some other ion is present. So you can try each of the tests, and at the end you will know. The test which will show you the result, it means that ion is actually present in a solution. Okay, that is how you test for different anions and cations. Okay, so these are all the questions that are related to chapter 11 to 22, and you have to memorize these concepts. Once you memorize, you can easily get 35 to 40 marks in your exam. Okay, you just have to memorize these basic concepts and all your paper will be related to these chapters. I hope these points are clear to you. And these are some of the now chemical process with their conditions. At least one question related to the conditions come in your exam. So you have to remember these all processes from and these are total 11 reaction that you have to remember in your for your exam, and I already have given these reaction in part 1. Okay, so you can just look at the part 1. These reactions are already given, the chemical process and with the conditions. I have collected all these chemical reactions from the whole book, so you don't have to open the book, just you have to memorize these 11 reactions with their conditions, and you can easily get 1 mark in your exam, because 1 mark will be at least from these reaction conditions. Okay, thank you and bye-bye.